A very good morning to my dear lecturers and fellow friends. My name is Ramanan Krishna Gopal from DEU 5A. Before I start this video, I would like to thank our frontliners who sacrificed themselves to fight with the global pandemic. Today, I would like to present my project. The title of my project is Room Disinfect using UV light. Due to global pandemic, the entire world went for a full lockdown. The economy of entire nation has been dropped significantly, and a lot of people suffer from no job and work from home. Our Malaysian government takes some serious steps to break the chain of infection. They came out with several standard operation procedures. After several time gap, finally the government give green light to the workers to work on their workplace, but with several conditions. One of the condition is the employer must sanitize their workplace before and after use. Due to these new rules, the companies are willing to do sanitize using the chemicals. To make their lives easy, I invented a device to sanitize a particular place without using any chemical substance like alcohol. I using UV radiation to sanitize the particular place. UV radiation is harm for human beings. It can give skin irritation and skin cancers. But with a proper execution and proper precaution, we still can use UVC light to kill microorganisms such as viruses, COVID-19. The objective of my project is to disinfect a particular closed place in a given time and without using any chemical. Using sanitization with alcohol will cost too much time and manpower, but using my device will cut the time and manpower that we need. Furthermore, using alcohol will have side effect in that workplace, but using the UVC light will not have any side effect and safe to use the workplace. After that, to build efficient disinfect device using Arduino Nano and ultraviolet lamp. Using Arduino Nano and UV lamp will make the cost of this device a bit cheaper. Thus, the small and medium companies can afford to buy this device and sanitize their workplace. Finally, to detect and eliminate dangerous microorganisms. This is the ultimate goal to achieve. I invented this device to eliminate most dangerous microorganisms such as coronaviruses. Move on to the methodology. I use Arduino Nano R3 is a main component of my project. It is a microcontroller which designed to govern with the UVC timer operation. The next is DHT11 temperature and humidity sensor. This sensor will measure the temperature of its environment and converts the input data to record. Move on to the UVC lamp. I use Philips TUV T8, known as a disinfect for air, water and non-porous surface. Besides that, I also use buzzer as an audio signaling device that alert the user. I also use a plastic box as a casing for the UVC lamp and wires. I also use wooden base as a strong basement for moving the plastic box. Finally, I use wires to connect the UVC to Arduino to set the timer. For the software part, I use Arduino IDE as an open source software to write code and upload it to the board. And finally, I use Proteus software, which is used primarily for electronic design automation. Right now, I want to talk about the flowchart of this project. Flowchart will tell us the flow of this project from the beginning to the end of the project. So we start. The user need to set the timer which is below to the 30. If the amount of the time is below to 30, then the microcontroller will set the timer and on the UVC light as a delay of 5 seconds. If the timer is more than 30 minutes, it will go back to the set timer manual because we set the timer is limit to the 30 minutes. So after the UVC light on, the timer will see until 30 minutes. If the up to 30 minutes, it will off the light automatically, which is very simple and easy to the users to understand it and access it. Move on to the block diagram. So as similar to the flowchart, the block diagram also show that the pathway of my project going. As we can say, the device will start and the user need to set the timer in between 0 to 30 minutes. So if the timer is less than 30 minutes, the device will on the UV lamp and take the reading of temperature and humidity of the surrounding using DHT11 sensor. If the temperature increase, it will adjust the intensity of the UVC light automatically. After the 30 minutes, the device will automatically turn off the UV lamp. It will easy and yet the user can understand and handle it with ease. Furthermore, these are the sketches of my project. As we can see, the basic sketch which is involved with Arduino Nano R3, the DHT11 sensor, the buzzer and the sensor which control the UVC light. Arduino Nano will instruct all the sensors to do its own work. The DHT11 sensor will take the reading of temperature and humidity and turn the analog input into digital and then send back to the Arduino. The sensor which control the UVC light will control the UVC light's intensity when the Arduino Nano know the temperature is too high or too low. And finally, the buzzer will alert the user when it will come in or go back with inside the particular places. Now we can see the PCB sketch, which is similar to the basic circuit switch. It is also involved with a basic Arduino Nano and a buzzer and two sensors, which is one is DHT11 sensor and one sensor which control the UVC light. Now we see the mechanical diagram of the entire project module. We can see the module in different position, which is side, front, side view, front view, back view. This is the exact look like of my project. So these are the results. Due to the insufficient time and lack of equipment, I am only able to do a prototype, but it will work perfectly as a full project module. So as I run the Proteus version of my project, it will work perfectly, which I can get the DHT11 reading of temperature and humidity, and the Arduino Nano is respect to the reading and try to change the intensity of my
UVC room disinfection device
will work perfectly.
is made with similar function to proprietary commercial system. In this case, the proprietary commercial system is similar to the sanitization using alcohol. The presented model can be easily scaled up, modifying its structures and programming by editing to open source code of the Arduino board or the Android application, achieving saving for more than 80% respect to the price of similar proprietary commercial equipment. I would like to thank my lecturer to give this opportunity for me to invent something useful, and I hope that I invented a device which is useful for the society. I also like to thank my supervisor Ponnor Hayati to guide me all the way to here and make my device a successful one. Thank you.